In this video, we will go over the in-text questions part of the gravitation chapter. Let's go one by one. I've already worked out the responses here, so just in the interest of time, so that we can go over the response and understand them in detail. So the first one, state the universal law of gravitation. So as stated by Newton, Sir Isaac Newton, the force of attraction between two objects, right, of any mass, the force of attraction between two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Right. So F is directly proportional to m1, m2 over d squared. And if you bring in the gravitational constant, it becomes like F equals m1, m2, F equals g times m1, m2 over d squared, right? So that is the universal law of gravitation. Just if I were to write it out, so it is F equals g times m1, m2 over d squared. That's the universal law of gravitation. Second one, write the formula to find the magnitude of the gravitational force between Earth and an object on the surface of the Earth. So in this case, your first object is the, let's consider Earth to be the object M and its mass is capital M. And let's consider the object, the smaller object that is placed on the surface of the Earth to be of mass small m, right? So in this case, we know that the Newton's law of gravitation can be written as F equals g times, which is a gravitational constant, times small m times capital M by r squared. R squared is nothing but the radius of the Earth. Because the object is placed on the Earth, you always have to look for the distance between the center of the object to the center of the other object. And in this case, you can approximate it to the radius of the Earth, because the object is very close to the surface of the Earth, right? So compared to that distance, the radius of the Earth is very high. So you can always consider you can approximate it to the radius of the Earth. So d can be replaced by r squared, and this is the formula, which is g times small m times m over r squared, where r is the radius of the Earth, capital M is the mass of the Earth, and small m is the mass of the object, and g is the gravitational constant. What do you mean by free fall? So a free fall is nothing but an object that is under the influence of Earth's gravity or the gravitational force of Earth. That's when we say that an object is on free fall. An apple that is falling on the Earth, it is on free fall. When it is on the influence on just Earth's gravity alone, it's on free fall. What do you mean by acceleration due to gravity? So acceleration that is experienced by an object during its free fall, right, towards the Earth is what we call as acceleration due to gravity. The acceleration experienced by an object due to the Earth's gravitational force is what is acceleration due to gravity, and we have already derived it to be 9.8 meters per second squared. What are the differences between the mass of an object and its weight? So we saw that mass is always measured in kilograms. The SI unit is kilograms, whereas weight is the force exerted by the mass, right? So weight is mass times the acceleration, right? So weight is nothing but force. While mass is measured in kilograms, weight is measured in newtons, or kilograms meters per second squared. So that is one key difference. And the second part is mass being a quantity, it will always have only a numeric value, whereas weight will have both a numeric and a direction value, because it is a force, right? So weight will have both numeric and direction. And the mass of an object is going to be a constant, wherever you place, it is irrespective of the gravitational force, right? So mass is a constant. A 5 kg object, an object of mass 5 kgs, will measure 5 kgs on the surface of the Earth, as well as it will measure 5 kgs in the surface of the moon or anywhere, right? However, the weight is the mass times the gravitational force. So it is not a constant, so it is variable. So the weight of an object in the moon will be different for the same object. The weight of the same object in the moon will be different, because On the moon, the object will be under the influence of the moon's gravity, not Earth's gravity, right? It's closer to the moon, so it will be in the influence of moon's gravity. So the weight of that object will be different, in fact, lesser, as moon's gravity is, is lesser too. And the other key difference is the mass of an object can never be, will not be zero, as long as it is, it is an object with certain mass, it can never be zero. It will stay the constant. But whereas the weight of an object can be zero at places wherever, when G is zero, the weight of the object becomes zero irrespective of its mass, right? So in the center of the Earth or in the center of the moon, you can think that the gravity is going to be zero. And in those places, the weight of that object is going to be zero as well. So that's another difference. Why is the weight of an object on the moon 1/6 of the weight of the 1/6 its weight on the Earth? So we saw that the acceleration due to the gravitational force in moon is 1/6 of what is experienced on the Earth. So the gravitational force in moon is lesser when compared to the gravitational force as experienced in the Earth. Mainly because of the size of the moon. The size of the moon is less, right? Size of the moon is smaller when compared to Earth. So whatever object that you keep, when you keep an object on the surface of the Earth, and when you keep an object on the surface of the moon, on the moon, when you multiply the mass of the moon and the mass of that object, is going to be less than the value that you get, the mass of the Earth times the mass of the object, right? So that is Newton's law of gravitation. So if you really put that into a picture, then you will find that the acceleration due to moon's gravity is 1/6, in fact, of what is experienced on the Earth. So if you apply that in the equation for weight, we know that weight of an object, if you consider the weight of an object in the moon is equal to mass times the gravity on the moon. Then the gravity of the moon you can equate it by the gravity on the Earth by the acceleration on Earth's gravity by 6, right? So when you equate that, it becomes like the weight on the moon becomes 1/6 of its weight on the Earth. So it's mainly because the acceleration due to gravity in the moon is 1/6 of what is experienced on the Earth, and that is what reflects on the weight also. Why is it difficult to hold a school bag having a strap made of a thin and a strong string? So we learned that when the strap is thin, right? Think about that example of a knife that we spoke about. When you apply a force on the handle of the knife, the idea is that all the force gets applied on a thin area, so that the pressure is high. So that that you end up cutting the fruit or the vegetable, right? So in this case also, it is the force is applied only on that string, and the thinner the string goes, it means that the pressure will increase, because pressure is the force the pressure is the thrust over unit area, right? So that is pressure. So when the unit area reduces because the strap is getting thin, which means that the pressure will increase. Higher the pressure, you will feel a pain, right? And that's why you will find it difficult. What do you mean by buoyancy? Buoyancy, we understood, it is a tendency of an object to float in a liquid, because the buoyant force is what is is upward the force provided by the liquid. And when it and that is what we saw it as, and as long as that buoyant force is less than the force exerted by that object, the object will sink. If the buoyant force is more than the force exerted by the object will start to float. And when the object floats, the phenomenon is called buoyancy, right? Whenever the buoyant force is more than the force of the exerted by the object, the phenomenon we experience is buoyancy. Why does an object float or sink when placed in the surface of water? As we discussed earlier, so it comes down to the relative density of the object, right? The density of the fluid and compared to the object. So primary reason is, when the force exerted by that object is more than the force, more than the buoyant force, right? Then the object is going to sink, and when the force exerted by the object is less than the buoyant force, the object is going to float. And the buoyant force, you calculate that buoyant force by the mass of the displaced water, right? And you calculate that, you calculate the mass of the displaced water by the density of water times the volume that is displaced. So it comes down to density. If the density is less, if the density of water is less when compared to the average density of the object will sink, and if the average density of the object is less when compared to the density of the water, the object will float. You find your mass to be 42 kgs on a weighing machine. Is your mass more or less than 42 kgs? Okay, so the question is very clear. So on a weighing scale, although the weighing scale measures only the weight, which is force. Now the question very clearly states that you can determine the mass, right? Because all what you need to do is from force, you just need to divide it by the gravity, and you get the mass. Let's say that the mass is 42 kgs. Now when I stand on a weighing scale and if it measures 42 kgs, if I consider this body, I have my hands, legs, my inner organs like my heart and lungs. Now, there is also enough air inside all of them, right? My lungs can hold approximately 6 liters of air. Now, all those will also be included in the mass that is, measured on the weighing scale. So, my average density, the average density of my body includes the air inside my lungs and all that, right? So if you really take my pure mass, it is going to be less than 42 kgs, right? My real mass is actually the mass of my body parts alone, excluding the air particles and all that, right? So yes, but the weighing scale will not be able to differentiate that, right? It gives me the mass of my body plus the air inside my body, right? So my real mass is actually less than 42 kgs. You have a bag of cotton and an iron bar, each indicating a mass of 100 kgs when measured on a weighing scale. In reality, one is heavier than the other. Can you say which one is heavier? Yeah, iron is heavier for the reason that the density of iron is more, right? So 1 kg of iron takes less space than 1 kg of cotton, right? But you would see that. The reason is because iron is more dense. And the density of iron is very high. Density is mass per unit volume, which is high for iron, and that's why it takes less space and less volume, right? Whereas cotton, though the mass is still the same as 100 kgs, it will take more volume, and density, which is mass over volume, is lesser. It's lesser for cotton. Since iron is more dense per unit volume, its mass is more. It means that it is going to be heavy, right? For any unit volume of iron, that will be heavier because its density is high. But whereas for that same unit of volume for cotton, it will be light because its density is less, right? So iron is heavier. So I hope this helped you. And in the next video, we will also talk about the exercise questions.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share and subscribe this with your friends. Thank you.